Alright, here's another example of finding arc length, but first we're going to focus just on kind of the algebra trick that we got to do. So 1 plus x to the minus 1/3 quantity squared is what's going to appear in the integrand on the next slide here. So what we're going to do is we're going to work this a little bit and see what we can do. Again, kind of the idea is somehow to maybe get a perfect square, or maybe to get something out of the square root so we can maybe do a u substitution. And that's what we're going to end up doing here, is doing a u sub. So we're going to go ahead and this will become 1 plus x to the minus 2/3, and common denominator is x to the 2/3. So we're going to go ahead and do that, and then we're going to factor out 1 over x to the 2/3, and then what we got left is x to the 2/3 plus 1. I did change the order. The order doesn't matter, so it could have been this. Doesn't matter. Okay. So this is going to be allowed to get out of a square root because it's a perfect square. It's a quantity squared, and we have multiplication. So we'd be doing this rule here: the square root of ab is equal to the square root of a times the square root of b. Okay. So we're going to go ahead and put this thing in the square root here. So you have x to the 2/3, and then x to the 2/3, 1 over x to the 2/3 times x to the 2/3 plus 1. We'll go ahead and slide that 1 over x to the 2/3 out by taking the square root of it. So it'll be just to the 1/3 power. Okay. And this is ready to go for a u substitution, so we're going to let u equal this, and then we'll see what our du is. So we'll let u equal x to the 2/3, then the du will be 2/3 x to the minus 1/3 dx. So if you want to kind of solve for dx in some respects, it'll have to be 1 over x to the 1/3. We'll have 3/2 du is equal to dx over x to the 1/3, and that's going to be our u substitution right there. Okay. So on the next slide, we're going to go ahead and get going on finding the arc length of a particular problem. So we're going to find the arc length of y equals 3/2 x to the 2/3 plus 4, and on the closed interval 1 over 27. So this is going to be continuously differentiable. So y prime is going to be x to the minus 1/3. And our arc length is integral from a to b, 1 plus y prime squared dx. So that's 1 to 27 square root of 1 plus x to the minus 1/3 squared. And this is exactly the thing we were working on the previous slide. So I'm going to forego all the steps again. You can see what those steps are on the previous slide, so that comes out. And we can go ahead and do that u substitution we just mentioned. So u is going to be the stuff inside the square root. Du will be 2/3 x to the minus 1/3 dx. Again, we'll go ahead and solve for the dx over x to the 1/3. And we can go ahead and do change of variable. So if we plug 1 in here, you're going to have 1 plus 1, which is going to be 2 as our lower limit. I'm going to go ahead and factor out the 3/2 also. So lower limit is 2, and then we're going to plug in 27. Okay, so if we plug in 27 to the 2/3 power, the 1/3 part of it is going to take the cube root of it, which is going to make it a 3, and then the square will change it into a 9, then the plus 1 will make that a 10. So our new limits of integration are 2 to 10, and then u to the 1/2 du. We'll go ahead and integrate it, and so we're going to add 1 to the exponents. It becomes u to the 3/2, and then we would divide by 3/2, but we already have a 3/2 on the outside, so those are going to offset each other. And then all we got to do is evaluate it from 2 to 10, and I went ahead and computed that ahead of time, and it's about 29. So you can go ahead and evaluate that on your own time. The change variable is not necessary, but I think it saves us a little bit of time here. Okay, so that's arc length.